Alright, welcome back to IMS Work Holding. We're going to be going over how to drill, countersink, and tap the 7 holes located on this part. This is the Titan 1M. It can be found on the Titans of CNC Academy. If you just want to click on their website, download the model, or create your own model. But this video purposes is just to do the holes. We've already done the facing, the adaptive, and the contouring for the cleanup. So we've got the base model. I'll show you where we left off at. So this is pretty much where we're at right now. Now we're going to come in here and do the holes, and I'm also going to go ahead and do the chamfer at the same time. So a couple different ways to do it. You can use hole recognition. For the model that I have, it doesn't really like to recognize the hole, so I'm going to do it on the more classical way of doing it. So I'm going to go to drill. I'm going to select a tool. So I'm going to use a 177 drill. I'm going to click OK. And then I'm going to go to geometry. And if you can, select the bottom of your hole, but you'll notice here that I can't. So I'm actually going to do this the long way. So I'm going to select all these little faces. It doesn't matter what orientation you select them in, it's going to automatically figure out the fastest path between. And something else that you can do is select one and then go here where it says select same diameter. It'll scan your model for all of the same ones. So now that I've got that done, I'm going to go to height. Now you'll notice I'm just going to the very tip of the chamfer. Now these holes need to be a 1/2 inch deep, so what I will actually do is go hole bottom minus 0.5. That way I know I've got the clearance in the bottom of the hole for the tap. There's nothing in cycle that I need to do because the material that we're going to be using, drilling straight down and pulling straight back out, is perfectly fine. And also I'm not going to use a center drill again because of the type of drill that we have and the type of material that we have. It's not necessary. We're using a full carbide drill. I know a lot of people like to spot where the hole starts, but the ground on center carbide drills do a great job in aluminum. There's really no reason to pre-drill unless you're drilling super deep. But this little 1/2 inch deep hole, we're not really worried about it. So at this point we're going to click OK. And now it's going to create that pop profile, and it's pretty simple. So now what I'll do is I'll right click and I'll actually duplicate this. And I'm going to duplicate it 2 times because I'm going to actually come back and tap. Then I'm going to come back. Actually, I'm going to chamfer the top of the hole. Then I'm going to come back and tap the part. So I'm going to change this one. So I'm going to edit. Change the tool that I'm using. Now I don't have a chamfer mill in here, so I'll create one right quick. So I'll go here. If you didn't see that, it's right here. I'll click on new tool. I'll come down to my cutter. I will change this to a spot drill, 90 degrees. The diameter that we have in shop is 250 thousandths in diameter, and everything else is completely fine with me. Click OK. Now I will come here to my height, change this back to 0, and now you'll notice that chamfer is going to line up. It's going to line up with what I have there. So at that point, only thing I have to do is click OK. It's going to change that. Then I'm going to go edit my other one by selecting right click edit, go into my tool, selecting my tap. This is a 190 by 32 or a 1032 tap. I'm going to click OK. The feeds and speeds on this is horrifically off, but it'll be fine for what we're doing. I am going to change my height to minus 0.375 because that is actually what the print spec is. I'm going to click OK. Then at that point I am actually done. But what I would recommend is coming in here and renaming these. So just double click on it. We'll, instead of it being drill whatever, it'll be chamfer. And then this one will be tap. So we're going to drill. I'm going to change that drill 1. I don't like seeing 1 on there. So drill, chamfer, tap. Now, unfortunately, with Fusion, it's not going to show you the thread when it taps. I wish that it did. I wish Fusion would work on that, but I understand the reasoning behind. You are going to see my model. If I turn my model off, you'll notice there's no hole, there's no thread there. You do see the chamfer that's there. So turn my model back on. Now, since we've already got our chamfer tool, we will actually just create a 2D contour. We're going to select our chamfer tool, which is tool 5 in this case. And an easy way, if you've got the model and the correct chamfer is on the model, is select the bottom of the chamfer. And then come in here to your passes. It'll automatically select chamfer, and the only thing you got to do is a tip offset. The tip offset is actually how much off the center line of the tool. So if I'm typing in 50 thousandths, I'm actually working on a 100 thousandths diameter of that chamfer mill. You can make chamfer mills last a long time if you're slowly work from the body down to the tip. You can get a lot of life out of a chamfer tool by just moving down, especially on very small chamfers. Why am I getting failed to write job file? That's interesting. So what doesn't it like? So, oh, chamfer width. I typed it into the wrong place. My bad on that one. So don't type it into the top one, type it into the second one. Then after that, you'll get your profile. I do leave lead in and lead out. It's just a cleaner effect on your chamfer. You do want to be careful on your feeds and speeds on a chamfer for a couple different reasons. One, if you're going too fast, you're going to leave what I call a ripple pattern where the chamfer mill can't keep up, especially if you're using like a single flute chamfering tool, like a drill press chamfering tool, chamfer tool itself. Then you're gonna leave that wave pattern, so you're gonna have to go really slow with a 1 flute tool. If you're using a 4 flute tool, you get a lot more speed behind it. And also another thing you want to do is make sure you're not going so fast that you're actually pushing off a little bit. So that's going to actually affect your blend line. So you want to be careful about that as well. So at this point, this Titan 1M is done. I'm going to come back and make a video with the hole recognition when I have a model that does better. I'll show you, this model was sent to me by somebody else. And what happens with this model is when I click on hole recognition, it recognizes all the holes, but it won't let me do anything with them. It's bringing it in as a dumb solid, probably an STL or IGIS or one of them two, where it legitimately doesn't know what to do. At this point, it's trying to gather tools and go through its sequence, but there's nothing for it to do, unfortunately. So if you have any questions, comments, concerns, please reach out to me via the comment section or any other means. Thank you for watching.